course, it works in exactly the same way as any other gene. There is room for 2 copies at the allele, and we have the superform, which is the visual recessive clown or the visual recessive cryptic, and the allelic form, cryptic clown, is the crypton, visually identical to the cryptic. Hi guys, it's Rob from Raw Balls. Today we're going to talk about the recessive allelic combination of cryptic and clown, which gives the crypton. First, I'd like to give another shout out to New Forest Morphs. They've been very supportive of my channel, and I'm wearing the shirt today, so big shout out to Paul and Jared at New Forest Morphs. Thank you very much for your support, guys. So let me first explain that I do not work with cryptic. So Cryptic Crypton Clown is not something that I can show you in my collection or show you any examples of. And you might say, well, don't make the video then. Many people have asked me to explain how the recessive allelic genetic combination works, and I can certainly do that from a genetic standpoint. We'll look at another pipe cleaner video explaining how the relationship works. So what we're going to do is to actually tell the story. Cryptic is a recessive gene, clown is a recessive gene, and most breeders are trying to get multiple combinations of recessive genes into their projects, and cryptic was an obvious candidate for getting into clowns, and so the first breeders would have attempted to make double hets. They would have bred a cryptic to a clown and expected to get normal looking animals, which were het for clown and het for cryptic, containing all the other genes that they wanted to add to their project. But as you will see, the breeders got a bit of a surprise. The results were not exactly what they expected. So let's have a look at that first attempt to make double hets, clown cryptic double hets, and have a look at the results that were produced. Over to Mr. DNA. Okay, let's see if we can figure out this whole cryptic crypton clown thing that is the latest craze in ball pythons. This is an allelic and recessive association, which seems to have thrown a few people off, but given our understanding of genetics, let's break it down, let's make it very simple, and let's tell the story. So breeders, being what they are always searching for double, triple, quadruple recessives, and the cryptic gene and the clown gene, the first breeders were trying to mix them together to get a cryptic clown. So let's do that. Let's make our double hets cryptic clowns in order to get the double recessive. So we'll start with a clown on the right, and because it's a recessive, it's carrying 2 copies of the clown gene at the address on the genetic material that clown resides at. So this is a visual clown, and we're going to pair it to a visual cryptic. Cryptic is also a recessive gene, which means that this snake is carrying 2 copies of the cryptic gene at the address that the cryptic gene resides at on the genetic material. Let's say the clown is a male and the female is the cryptic, but it doesn't matter, it could be the other way round, the sex is irrelevant, but we're going to use yellow for clown and we're going to use red for cryptic. So when we produce our hets, we expect to get double hets. When you split the genetic material in half, it doesn't matter which half of the male you choose, you are going to get 1 copy of the clown gene. Okay, we split the genetic material in half. Father provides half of the genetic material and mother provides the other half, so it doesn't matter which half you choose to pair to the female, you are going to get 1 copy of the clown gene transferred. So these babies are all going to be 100% het for clown. Likewise, we take our cryptic and it doesn't matter which half of the female you take and pair to which half of the male, every single baby is going to have one copy of the cryptic gene. Okay, so we've produced our double hets. We expected them to look non-clown and non-cryptic, but what we actually got when we paired this half of the male to this half of the female is one cryptic and one clown. We pair to this half of the female and we get one cryptic, one clown. We take the other half of the male and pair to this half of the female, one cryptic and one clown. And this half of the male to the other half of the female, and we get one cryptic and one clown. So those are our double hets. All the babies are carrying one copy of the clown gene and one copy of the cryptic gene. And imagine the surprise when these did not look like non-clowns and non-cryptics. Normally we would have expected to have produced babies that have one copy of cryptic and one copy of clown, completely independent to each other, residing at different locations on the genetic material. And that would be the same as any other double recessive. They would look like normals, or normals with the other genes that we have put into the mix. So imagine the surprise when all of these babies looked like cryptics. They looked like visual recessive cryptics. And we now understand that what we have actually produced is an allelic combination where each baby carries one copy of the clown gene, one copy of the cryptic gene at the same address at opposite sides of the allele or the locus. So this is an allelic relationship, and it happens to be a recessive relationship, which means that you do still need to have two copies to get a visual recessive. If we do not have the two copies, for instance if we only have a het cryptic, these will all look like normals. If we only have one copy of the clown gene, these will all be het for clown, but they will look like normals. Because we've produced a double het and everything looks cryptic, the allelic reaction between cryptic and clown means that everything looks visual cryptic. The clown is substituting for the second copy of the cryptic, and it's cryptic that is visually dominant. So this double het is an allelic combination that looks like a cryptic. And to differentiate between a true cryptic and one which is het for clown and het for cryptic, we've coined the term krypton. Visually, they look exactly the same as cryptics. But a krypton is a double het clown cryptic. This is what we've produced here. So this is where it gets interesting in terms of the recessive element of this ALS combo, is that when you have a double het, it looks just like the visual cryptic. So how do we know which is which? Okay, now that we've looked at cryptic and clown and seen how we produced the first kryptons, which are actually 100% het for clown, 100% het for cryptic, and consequently because they are 100% het but look like cryptics, we call them kryptons to differentiate them. As far as I'm aware, there is no visual difference between a cryptic and a krypton. You wouldn't be able to tell. So let's have a look at what happens when you breed a krypton to a krypton. In this case it's double het to double het, but because it's a recessive allelic combination, the results are not 1 in 4 for het to het and 1 in 16 for double het. The results are quite different. Let's take a look at that. So inevitably we're going to pair het to het. So we've got our double het clown cryptic or krypton, paired to another crypton, and because it's allelic, when you split the genetic material, each of the babies is going to receive either a copy of the clown gene or a copy of the cryptic gene. Same for the female, each of the babies is going to get a copy of the clown gene or a copy of the cryptic gene. So let's do that. These two parents here are cryptons, so they look like visual cryptic. There is no indication at all that they are carrying het for clown. The only way you would know that is if you breed them yourself and you've produced them and you get a bunch of cryptic looking animals that you know have to be 100% het for clown. So we split the genetic material in half and we pair this half of the male to this half of the female, and we get one copy of clown and one copy of cryptic. So we've produced a crypton, but visually it looks just like a cryptic. We pair this half of the male to this half of the female, and this time we get two copies of cryptic. This is a visual cryptic. It looks exactly the same as this one. They both look visual cryptic, but this one is crypton, this one is cryptic. We take the other half of the male, and this half is carrying the clown gene. We pair it to this half of the female, and this time we get two copies of clown. This is a visual clown. Easy to distinguish from the other two because this is a clown. We take this half of the male, again carrying the clown gene, and pair it to this half of the female, and again we get one copy of cryptic, one copy of clown. So you can see that het to het, the 1 in 4 relationship holds. We've paired a het clown to a het clown, and we have 1 in 4 of the babies are visual clowns. We've paired het cryptic to het cryptic, and we have one baby which is visual cryptic. 1 in 4 is a visual cryptic. The only problem in this relationship is that the other 3, one is a visual clown, the other 2 are cryptons and look exactly like the homozygous form of cryptic. So when you pair het to het, you can easily pick out the visual clown, but you have no idea which are your cryptics and which are your cryptons. So it makes the allelic relationship even more difficult to work with than a normal ALS combination. Okay guys, so as in any allelic combination, we know that asphalt yellowbelly in the freeway complex, for instance, can produce combinations of snakes that are very difficult to identify, and this is particularly difficult to identify because cryptic and crypton, the double hets, look exactly like cryptic recessives. We know there are 2 genes on the allele, but the recessive allelic combination of cryptic and clown produces a crypton which looks exactly like a cryptic. So we have the same issue when we're working with an allelic recessive complex as we do with any allelic complex. The key to reducing uncertainty in the offspring is to use the superform as one of the parents, and in this case the superform would be the visual recessive. So we can use a visual recessive clown, and also we could use a visual recessive cryptic in order to control the outcome when we pair it to a crypton, which is the double het. So let's have a look at what happens when we do that. So again, the key to any allelic project is to use the superform rather than pair the allelic combination to the allelic combination. So let's do that. Let's pair a visual clown, the superform of clown, to a crypton, which is the double het cryptic clown, and see what we get. Okay, so the key to any allelic project, including a recessive allelic project, is to use a superform. So we're going to pair a clown to a crypton, which is the double het cryptic clown, and see what we get. Here's the male, a visual clown. Here's the female, who is Crypton. She looks like a cryptic, but we bred her ourselves so that we know that she is the double het Crypton. So we take this side of the male's genetic material and pair to this half of the female, and we get one copy of clown from the male and one copy of clown from the female. This is a visual clown. We take this half of the male and pair to this half of the female, and this time we get one copy of clown and one copy of cryptic. So this is visually a cryptic, but we know it must be a Crypton because of the pairing. We take this half of the male and pair to this half of the female, and we get one copy of clown from the male, one copy of clown from the female, so we get another visual clown. And we take this half of the male and pair to this half of the female, which is carrying the cryptic gene, and we get one copy of clown and one copy of cryptic. So we get an animal that looks like cryptic but is actually a Crypton. Because of the pairing, we know it must be het. So here you are pairing a het to a visual clown, so half the babies are visual clowns, but because the other half of the female is carrying the cryptic gene, half of the babies are not going to be just het for clown, they're also going to be het for cryptic, which means that they are Cryptons. So by using the superform or the visual recessive clown as one of the parents, we can control the outcome in the same way as any other allelic combination. We produce half visual clowns and half Cryptons, and we know they must be Cryptons rather than cryptics because we've paired a visual clown to a 100% het cryptic, het clown or Crypton that we produced ourselves. So notice in the het to het pairing we introduce uncertainty. We do not know which of the babies are cryptics and which are Cryptons, but by using the superform we can control the outcome in just the same way as any other allelic combination. So the allelic recessive combination adds a twist. When we normally work with allelic combinations, they are codominant combinations, and therefore visually the offspring, regardless of whether they're one gene or the other, we can tell them apart. In this particular case, where we have cryptic and Crypton as the outcomes, we cannot tell them apart. It makes it more difficult. Because they're allelic and they're recessive, the 100% double het cryptic clown looks just like a cryptic, and we call it a Crypton to distinguish it from the cryptic. So you can see how the story developed. Initially there was a lot of confusion. Are all my clowns actually het cryptic? Because when we pair them together I'm not getting double hets, I'm getting everything that looks like cryptic. How can that be? Well, we now understand, of course, that the genes are allelic, and of course clown and cryptic together look like cryptic. So that's the story behind the cryptic, Crypton, clown allelic combination. So it's a double recessive, and the genes occupy the same locus on the genetic material, and they act like super. So your Crypton is either going to give a copy of clown or a copy of cryptic. It will not give you a normal. It's one or the other. So it works in just the same way as any other ALS combination, except the visual expression is actually a visual recessive expression, and clown, cryptic, we call Crypton, looks just like a visual cryptic. You cannot distinguish between the two. So unless you've bred them and you know what the outcome is, you cannot tell them apart. So in this particular case, we can harness the power of ALS by using a superform, and it doesn't matter if you use a visual clown or a visual cryptic. You control the outcome, so there's no uncertainty of what the babies are, but we introduce uncertainty and we're not sure what the babies are when we pair double het to double het. Some of the babies will be cryptic, true cryptic with 2 copies of the cryptic gene, and some of the babies will be cryptons with 1 copy of clown and 1 copy of cryptic, but we cannot tell them apart, which makes it more difficult to work with the double recessive allelic combination. So that's the story, guys. That's cryptic, crypton, clown, and that's how it works genetically. I think you already knew how it worked from some of my previous Mr. DNA videos. It works in exactly the same way as any other gene. There is room for 2 copies at the allele, and we have the superform, which is the visual recessive clown or the visual recessive cryptic, and the allelic form, cryptic clown, is the crypton, visually identical to the cryptic. Okay guys, so that's how, from a genetic standpoint, the recessive allelic cryptic crypton clown combination works. As I said, I am not really qualified to show you any examples of these various morphs because I don't work with them, but I certainly understand how the genetics work if I was to attempt to work with them. So I've outlined that for you today. I hope that helps in your understanding of how a recessive allelic combination works. Funnily enough, although it is quite trendy now when we talk about cryptons, recessive allelic combinations are not unknown. For instance, we have the albino, toffino, candino complex, which is also a recessive allelic complex. So the crypton is not the first recessive allelic complex. They are known in the industry, so not at all unusual. So that's it for today. Jump down in the comments below if you want to ask me any questions or you want to criticize me for producing a video with combinations of animals that I don't actually have in my collection. I will take that one. It's a valid criticism, but people did ask me to explain the genetics. I've also had several questions lately on the banana and sex-link gene, which I've done a video on before, but these questions have related to the superform and super bananas. So jump down in the comments if you would like me to cover the sex-link in the superform of bananas and explain how that combination works and what you can expect in the offspring from a super banana. I think I'm going to do that video anyway because I quite like it. So thanks for watching. Don't forget to share, like and subscribe. Thanks to New Forest Morphs, and we'll see you next time.